In the second half of 7.4, just a little bit more, 5 minutes maybe, we have to talk about molecular formulas. Okay, what molecular formulas are is they're the actual formula of the compound that does exist. So let's look at a list here. So benzene, and hopefully we can see this, is C6H6. That's its molecular formula. But if we solved a problem trying to solve for the empirical formula, we'd get CH. So that is the smallest ratio of the elements that is there, the smallest whole number ratio of what's present. Hexene, C6H12, empirical formula, notice we can reduce that to CH2. Now, notice like with water, sometimes what the molecular formula is what the empirical formula is. So it's not like we can reduce everything. One place where that's true is, notice, with water, also with something like sodium carbonate. So just things like phosphoric acid, notice its molecular formula is its empirical formula. So some things, the molecular formula is going to be much, much bigger than its smallest whole number ratio, but other things it's not. So we just have to be careful of that when we go into empirical formula problems. So here's kind of a classic one. It says, what is the molecular formula of a compound that has an empirical formula? So here's its empirical formula, but its mass is 60.12 grams. The molecular mass, so that's grams per mole. Well, how do we figure out what the molecular formula was? Well, we'd start by adding up everything that's here. Notice if we add that all up, we get 30 grams. Well, if everything that's there is 30 grams per mole, but the molecular mass is 60, notice we'll divide what's there by the molecular mass, and it goes into about 2. That is telling us that the true mass of the substance, or the true formula of the substance, is double what the mass of the empirical formula is. So we'd take that empirical formula, we'd multiply it by 2, and so we'd multiply it all the way across. So the 2 goes to 2 carbons, 8 hydrogens, and 2 nitrogens. So again, the mass of the empirical formula is going to be, again, its smallest mass of that one particular unit. If it's some ratio of that, we should be able to divide that mass into whatever the molecular mass is to find what that ratio is. Here's a slightly more advanced problem, and I'll walk you through what they're doing here. So first, this is set up like an empirical formula. So notice they give you a mass of carbon, a mass of hydrogen, a mass of oxygen. And what they have you do with it first is convert them all to moles. So this is what we are doing with empirical formulas, and we get these molar numbers. Now, so this is our step 1, is convert everything to moles. Step 2 here is we're dividing all of them by the smallest number. Notice 0.818 is the smallest, and we get a ratio of 1 to 2 to 1. So that is our empirical formula. That's what we are solving for in our empirical formula problems. But if it tells you something like, that's the empirical formula, but the molecular mass is 90 grams, now, what is the molecular formula? Well, if they give you the mass and you have to figure out the empirical, well, just like that previous problem, we'd look at this and say, well, it's CH2O, just like here. We'd add those pieces up. Carbon is 12, oxygen is approximately 2 times 1, I should say, to get us 2, and oxygen 16. That's where they get this 30 number on the problem. That's the mass of the empirical formula. Divide that into the molecular mass that they would have to give you in the problem, and it tells you what ratio of that compound is its molecular formula. So notice then they take that 3, they multiply it through the empirical formula. We get 3 carbons, 6 hydrogens, and 3 oxygens. So molecular formulas, yes, these are both molecular formulas. Water's a molecular formula. Toluene, we can't reduce that. That is a molecular formula. Thank you for asking the question.